In this section, we'll look at why BPE tokenization matters so much in cross-lingual large language models. For AI engineers working with multilingual systems and agents, tokenization directly affects efficiency, cost, and model behavior across languages. A tokenizer built around one language can fragment another, which hurts performance. So understanding BPE is a practical step toward building LLM applications that work more reliably across diverse linguistic settings. Byte Pair Encoding, or BPE, is a tokenization method that builds words from the bottom up. It starts with individual characters, then repeatedly merges the symbol pairs that appear most often, creating common subwords. This continues until the vocabulary reaches a chosen size. The benefit is a practical middle ground, more flexible than fixed word lists, but much more efficient than treating every character separately, especially in multilingual systems. The core challenge is scale with diversity. A single multilingual model has to handle dozens of languages, each with its own script, word structure, and usage patterns. The tokenizer and vocabulary have to be broad enough to represent all of that, but still compact enough to keep the embedding table manageable. If that balance fails, the model either becomes too large or loses important rare forms by breaking them into poor or unknown tokens. One of the biggest problems with word-level vocabularies is rare words. In multilingual data, you either make the vocabulary enormous to cover inflections, names, and compounds, or you map unseen words to a useless, unknown token. BPE gives us a better option. Instead of dropping a word like unaffectionately, it breaks it into familiar subword pieces like un, affect, ion, and ately, so the model can still capture meaning. A big advantage of multilingual models is the shared subword vocabulary. When related languages, transliterated words, numbers, punctuation, or borrowed terms use the same pieces, the model can reuse what it has already learned. That makes parameter sharing practical and helps transfer knowledge across languages. Even between pairs, it never trained on directly. Those shared pieces also support more universal internal representations, giving the model more chances to connect patterns across all its training data. Efficiency here is really a vocabulary design decision. The core trade-off is simple. A larger vocabulary usually means fewer tokens per sentence, but higher embedding costs. A smaller vocabulary makes embeddings cheaper, but sequences get longer. That choice directly affects inference cost, context, window pressure, and throughput. A useful metric is fertility, or average tokens per word. Recent studies across 38 European languages show that tokenizer design can significantly change sequence length at scale. You can think of tokenization as a compression problem. If segmentation is better aligned to the language, we get cleaner subword splits and lower token counts for the same input. That means each context window carries more meaning, sequences are shorter, and inference gets cheaper because the model processes fewer tokens. Being able to connect tokenizer design all the way to serving cost is a strong signal of real production systems thinking. SentencePiece is language independent by design. It learns directly from raw text as Unicode, so it doesn't rely on spaces, language-specific rules, or custom pre-processing pipelines. That means it works well for languages like Chinese, Japanese, and Thai, as well as space-delimited languages. But it's also more tolerant of noisy mixed script input and inconsistent normalization, which helps reduce failure points and makes multilingual production systems much more robust. To be honest, BPE is not always the answer. A strong engineer recognizes its limits. Tokenization behaves differently across languages, so there's no universal winner. In some low-resource or multilingual translation tasks, character-level models can perform just as well, or even better. And BPE itself is sensitive to vocabulary size, pre-tokenization, and the corpus it's fit on. So the right takeaway is, BPE is a strong default, but its value depends on what you're building and how you measure it. Here's the landscape of common tokenization approaches. BPE, often used through SentencePiece, gives us an open vocabulary, shares subwords across languages, and stays language independent, but its quality depends a lot on the training corpus and vocabulary size, and it can oversegment morphologically rich languages. Unigram is more flexible and probabilistic, though less intuitive. Character level works on any script but creates long sequences, while word level is simple and interpretable, but breaks on rare or unseen words. This is a strong hiring signal because it shows you understand more than just prompting. If you can clearly explain how tokenizer design affects what the model sees, how efficiently it learns, and how it behaves downstream, you're showing real stack awareness. That tells interviewers you can reason across the layer between raw data and model behavior, which is exactly what many LLM teams are looking for. This knowledge matters in several key roles. For multilingual assistants, tokenizer quality shapes both response quality and cost across languages. In retrieval systems, subword segmentation influences embedding quality and cross-lingual recall. For translation and localization, fertility and vocabulary coverage affect fluency and serving cost at scale. And in region-specific AI products, language-independent tokenizers help reduce pipeline fragility across different markets and locales. Here are 5 interview questions you should be ready to answer on multilingual tokenization. Be prepared to explain why word-level vocabularies break down because of rare words, huge vocab sizes, and unknown token issues. You should also discuss the trade-off between vocabulary size and sequence length, why shared subwords improve cross-lingual transfer, where BPE struggles in morphologically rich languages, and how to evaluate a tokenizer using fertility, robustness, and downstream performance. A strong interview answer avoids absolute claims. Don't say cross-lingual success comes from tokenization alone, or that BPE is always best. Instead, say BPE often offers a good balance of open vocabulary coverage, parameter efficiency, and cross-language sharing, but its impact depends on things like vocabulary size, corpus mix, language family, and the task you're evaluating. It also helps to mention alternatives like SentencePiece or character-level methods, especially in low-resource multilingual settings. Portfolio projects are where understanding becomes visible. Instead of just repeating concepts, you're showing that you can actually apply them to solve real problems. A strong project gives people something measurable to look at: your decisions, your process, and your results. That's what makes projects so powerful. They turn knowledge into evidence and help demonstrate what you're capable of doing in practice. Here are 3 strong portfolio project ideas. First, a multilingual tokenizer audit. Train or compare tokenizers across English and a few other languages, then measure fertility, out-of-domain robustness, and impact on tasks like classification or retrieval. Second, a product-oriented cost benchmark, looking at token counts and latency in multilingual support chats. Third, a low-resource adaptation study, using SentencePiece to test how raw text and vocabulary design affect quality in a new language or dialect. 2 core tools to know are Hugging Face tokenizers and SentencePiece. Hugging Face is great for fast training and inference, with support for BPE, WordPiece, and Unigram. SentencePiece is the go-to for language-independent tokenization, especially in multilingual settings. But what employers really want is judgment: how you designed the corpus, why you chose specific normalization and vocabulary size, and how you evaluated trade-offs like fertility, out-of-domain performance, and latency. When evaluating multilingual tokenizers, 3 metrics really matter: fertility, out-of-domain robustness, and downstream task performance. Recent European multilingual BPE studies looked across 38 languages and compared configurations like a 128K SentencePiece vocabulary and a larger 262K setup. The trade-off is straightforward. Bigger vocabularies usually mean fewer tokens per word, but they also increase embedding cost. That balance is what separates a rigorous tokenizer evaluation from a superficial one. What sets strong LLM engineers apart is systems thinking, being able to connect the whole stack. It starts with the data, how you collect, clean, and normalize it. That shapes tokenization, which influences model behavior and ultimately shows up in the product experience. Teams value engineers who can reason across that entire chain, from representation to user impact, not just explain transformer internals. The bottom line is that BPE is the practical default because it solves several real-world problems at once. It handles rare words much better than fixed-word vocabularies, works well across languages, and allows useful sharing of subword pieces that can support transfer. It also fits production needs, since vocabulary size is set in advance with clear trade-offs. And with tools like SentencePiece, it stays language independent across different scripts.